Hello, everyone, and welcome to my talk. Thank you so much for joining. My name is Taylor Murphy. I'm the head of product and data at Meltano. I've been asked to direct you over to the Discord where there's a live Q&A taking place. You can just scan the QR code. Hopefully you've enjoyed the talk so far, our keynote from James Dendmore and the talk about snowplow from Alex Dean. I'm here to talk about Meltano and more specifically extraction and loading within the context of the open source data stack. I'm sure you've seen this slide. Everybody's going to be talking about it. Meltano fits in here. We are focused on extraction and loading, so getting your data from databases, internal, external, third-party SaaS APIs, different files into your data warehouse. Of course, this is all in the context of this fictitious company, Yukon. They're a global e-commerce company selling a bunch of stuff, but most importantly, I think for this talk is they have a data team. Data analysts, engineers, analytics engineers, data scientists. I'm guessing a couple of managers as well, since that's a lot of people not to have a manager. And they're all working together on a shared mission. And this is really great news because if they have a data team, that means you can assume that they do have some support at the executive level. And I'm kind of making some of these assumptions, but I think it'll help the talk. We can assume they have some funding, but probably not enough to go full beans. They couldn't go buy just whatever they wanted to. And I'm also going to assume that the team is kind of getting off the ground. Maybe they hired a bunch of people in, or they're really starting to take a hard look at how they want to grow the data platform and the data product. And they're making some immediate build versus buy decisions. There's two more things that I want to highlight and get out there for the purpose of this talk. One is, what is the purpose of a data team? And the other is how to frame how data teams work and how to think about how data teams work. These next 2 points are taken from a talk that I gave with Emily Sherio at Coalesce 2020. And so if you attended that talk, you'll see some repeated themes, but I think it's good to highlight here. What is the purpose of a data team? We had posited and still think that the purpose is to help organizations make better decisions. Everything that a data team is doing should be focused on better decision-making, whether it's building models, building reports. It's all in the end about getting that information and making a decision from it. Now, how should a data team work? Well, looking at this conference in particular, and then the conversations that are happening around the modern data stack, we see data teams as building a data product. They're building products and adding tools to the tool chain to achieve the outcomes of the goals of the team, which is to help the company make better decisions. But what is the data product? So the data product is every piece of data that is flowing between people, systems, and processes. Every analysis that the team is producing, every dashboard, every BI tool, but also every tool that has some sort of analytic capability built into it, such as Zendesk or Salesforce, that is part of the data product. Every spreadsheet, every CSV, every Google Sheet, that is also part of the data product. And you can think about all of these things as feature sets of your data product. But more simply put, if people are using it to make decisions, it's part of the data product. Now, what isn't part of the data product? Well, one thing that isn't part of the data product is individual pieces, in that the individual piece is not the data product in itself. You can't look at your data warehouse and say, this is my data product. That's not it. The warehouse, the BI tool, the data platform, they're all part of the product. The main thing that's not part of the product is the myriad other jobs that your colleagues are doing within your organization, whether it's talking to customers, responding to support tickets. They may generate data that winds up as part of your data product, but those jobs in themselves are not part of the data product. So why are we framing it this way? Well, we've taken a look at a lot of great companies, and a lot of them are product-led organizations. They have really good products, but they also have really strong product teams. These teams are made up of a diverse array of people with different backgrounds and skill sets, and they're all coming together to focus on solving customer problems in the best and most efficient way possible. Good product teams have a vision and a strategy on where their product is going, and they also drive really good business outcomes for the organization. Revenue in the case of for-profit enterprises, but also driving towards the mission and vision of the organization. And we want all of this for data teams as well. We think data teams should have a clear vision and strategy. We believe they should have a deep understanding of their customers, who in this case are your coworkers. We think Teams should have a lot of great people with a diverse set of skills. And we're seeing this today with the rise of analytics engineers, machine learning engineers, data product managers. All of this, and with all these great people, you can think of yourselves as working to iterate on the feature set of the data product rather than being stuck in the service model. And again, all of this is to empower the company to make the best decisions possible. So as a data leader, and I include everyone that's on the data team, certainly for the purposes of this talk, as a data leader. If you're on the data team, you have a skill set, you have opinions about how data should be used and transformed. So in that case, you are a data leader, and you can help guide the strategy and feature set of the data product. So with all of that out of the way, let's get back to UConn, who is building their own data product, but more importantly, they've got their own set of questions that they're trying to answer. They've got a set of metrics. And this is a really exciting thing to see. The company has, the data team has taken the time to engage with the business to ask tough questions about what is important to measure, what do you care about, what decisions are you going to make, and they come back to the table with this set of metrics. And with this in place, and we could debate all day whether these are the right metrics, but let's go with this assumption that this is what we're using. From here, you can back solve to what data sources are we going to be pulling from to actually answer these questions. And so these are the tools that UConn is using today and what we're pulling from. We know we're going to Snowflake as our data warehouse. We're pulling from a transactional DB, in this case, Postgres. And then we've got a variety of different SaaS tools such as Zendesk and Marketo, and then some ads tools as well for Google and Facebook. Okay. So with all the groundwork out there, we know what the data team's doing, what its purpose is, we know where we're aiming for, we know what tools we have. All of the requirements are in place, and let's go on a journey. And be warned, this journey has a lot of gifts with it. So let's have fun with that. So we're going to leap 3 years into the future with UConn. What do you think theirs, and really your, extract and load requirements are going to look like? Do you think they're going to be almost identical to where they are today? Probably not. What are some things that are going to be true 3 years from now? Most likely, you're going to have some really strict security, privacy, and compliance requirements. As organizations grow, this tends to be the case. You get compliance people, auditors in there. There's just going to be a little bit stricter control around everything that you're doing. You're probably going to have a larger team, but you may have a tighter budget as well. Financing doesn't always scale one-to-one with headcount. You're certainly going to have more mature processes, whether that's internal to your data organization or within the organization more broadly. There's just going to be more things you have to do to get things done. Perhaps there's more sophisticated tooling across engineering and other organizations. And I think most critically, your data sources, or rather UConn's data sources, are going to grow from this small set to this and then some. You're going to have more third-party tools. You're going to have more databases. You're certainly going to have some spreadsheets that you're going to have to pull some data from. There's going to be a diverse array, and you don't know upfront what you're going to have in the future. So with all this in mind, thinking forward into the future, what's the worst that could happen? What's kind of the worst outcome if you make a decision now? What could be some of the effects of that decision 3 years down the road? Well, in my mind, this is kind of the worst case scenario. You wind up with a tool or stack that doesn't support all of the weird APIs, databases, and files that you're going to absolutely have. You're just going to have a bunch of different sources, as I mentioned, and if your tool doesn't support it, you're going to be in some trouble. Another bad outcome would be that your tool doesn't work well with your existing stack or processes, whether that's integrating with the tools that the software engineering team is using, or if you've made decisions about other tools, if it doesn't work well, it's going to be a big challenge. Another potentially bad outcome is that to add more data sources, you need to negotiate a new contract. That's not fun. As I mentioned, the security, privacy, and compliance concerns, particularly around internal databases, may become a concern. I saw this at GitLab, where we're trying to pull data from an internal database and having to go through the machinations to actually make that happen and stay within the boundaries of security, privacy, and compliance. Then another potentially bad outcome is having to engage with a support team that maybe is not as helpful as you'd like them to be, maybe because you're on a lower tier, maybe the company that you've chosen to work with doesn't have a great support team, but in either case, it's just kind of a one-to-one relationship. You have to go to them and wait for them to help you. This is bad. This is not a great outcome. Some would say this is the worst. So let's flip the script. What's the best that could happen? What's kind of the best case scenario? And really, I think it's just the opposite of the worst case. You have a tool and a stack that does support a diverse array of data sources and weird APIs. Your tool is flexible and can integrate well with your existing stack and with stacks that you may not even be aware of exist in your company. There's just no need to have these extra negotiations for additional sources. You've solved and ameliorated all the challenges that you're seeing around security, privacy, and compliance, all within the same tool. And I think the most exciting best case scenario for me is you now have a support community that is extremely helpful. Instead of having a one-to-one relationship with the business, you're able to connect with users and other people in your profession and in the ecosystem to gain help and to solve your problems. Okay, so how do we get there? How do we go? How do we make the small decisions, and what do we need to be thinking about to avoid the worst case scenario and achieve the best case scenario? I think it comes down to 3 key attributes that I want to talk about for the rest of the talk. Those are open source. This being the Open Source Data Stack Conference, I think that's kind of obvious, but I want to dive in and explain why that's important. I think a standards-based approach is also going to be critical, particularly for the extract and load phase of your data stack. And then I think having a DataOps first mentality is very critical and will become more critical in the intervening years as data teams grow and as we all become better at doing this job. So let's start with open source. Why open source? And I kind of teased it at the end of what's the best case scenario, but open source generally is all about community. And the way that people work, when you're able to be transparent and open about what you're working on, how things work, where the code lives, where the issues are, who's working on it, it invites people in. And we see, I think the best example of this by far is of course, DBT Labs and DBT, the product. They've built a great product that is open source, that invites people in, and they built one of the best communities in the data profession for getting work done. And I'm excited for you to hear more from Julia tomorrow about DBT. Open source also is more accessible, and this ties back to community. But by being open source, and typically there are free versions of these products, even if there's a paid offering, by having a free version that is open source, it invites more of the world to be able to use the product and to benefit from the best practices. We've seen at Meltano that there are places in the world that don't have the resources that we do, and maybe can't afford to pay the prices that American companies want to charge. And so by having an open source product, you really unlock that access for folks to engage in the best practices of their profession in the current day. And the last point about open source, which I think speaks to the flexibility of a given tool, is the fact that the code is open. And generally this means that the tool is going to be fixable, it's going to be debuggable, and it really empowers you and gives you control. When you can see the code, when you can understand stack traces, when you can deploy it yourself, it empowers you to understand how it works, and to fix problems when you see them. And you can also, deploy this in your own environment. You aren't stuck with what one company says you have to do. You can put it wherever you need to. And so it is very empowering and kind of gives you that control back. So given that you're at this conference, I won't belabor the point that open source is an important part of the decision-making process for any given tool in the modern data stack. Let's dive into standards-based. Why is a standards-based approach important? I think the first thing, and I'll spend a few minutes on this, is that when there is a known specification, if you are able to build to the spec, you know that it's going to work. In the context of extraction and loading, this is really, really powerful. If you build a connector for a given database and you say, this is how I expect all the data to come in, and you put that out there in the world, suddenly you can build thousands of connectors that can all feed into that one target, that one connector into that database. Now you're able to collaborate with a worldwide audience that are using very similar products. You're going to have a large catalog of connectors to work with, and you just know that it's going to work, because all you have to think about is kind of building to the spec. and it really creates the opportunity to solve a lot more problems than any one organization could. No one company is going to be able to build every connector that you need, especially if it's in a point-to-point from one database to one API and on and on and on. You build to a standard and it allows everything to funnel in. Standards are really good. We've seen this with SQL in particular, and again, referencing DBT Labs. They standardized on SQL, and that has just unlocked a huge amount of collaboration and community. And speaking of community, again, it brings more people in. When there's a shared standard, you don't have to really argue or debate about like what is the standard. Of course, we do that. There are ways everything can be improved, and that is a part of the discourse, is improving standards. But it allows you to get work done and focus on solving more interesting problems, and also allows you to share that work. And sharing that work means that it's reusable for a lot of people. As you move through your career to different organizations, you're able to carry those tools and also that experience to different organizations. You're not locked in because you've gained your chops on one specific tool. If you build something at one place, if it's open source, you can take it to another place. This is really powerful for organizations, but also for you as an individual. And I think it does speak to the power of open source and standards to really enable your employees to be really happy, because they know that they're not learning something that's just going to go to waste if they ever have to leave your company. So we're talking about standards, but I'm not talking about SQL. So which standard for extract and load are we talking about here? Well, the one that we really believe in as Meltano is the Singer open source standard for moving data. It is the de facto standard for moving data at this point. It was launched in 2017. It is currently in use by fantastic companies and a fantastic community around the world. It by far has the largest Slack community with over 4,000 people in the Singer Slack alone, and that's not including any of the supporting Slack groups such as Meltano's. This screenshot here is an example of what the data looks like according to the Singer spec, but really it's not important what the spec actually looks like. Just knowing that it exists and that you're able to write to it, and we built some tools to make that easier, is where a lot of the power comes from. And the assertion that this is kind of the de facto standard is supported by Singer having the most connectors in any sort of data movement ecosystem by far. This 300 number is counts both taps, so pulling data from different sources, and targets to where you want to push the data. And we've helped catalog a lot of these, and we see new ones being built every day. And there's some from APIs that you've never heard of, and there's some that we haven't even cataloged quite yet. People are very active in this community, and it's one of the better ones out there. And like I said, it's a large community. We all have data movement problems. We're all solving similar problems, and we hear every day that people are excited to be a part of the Singer community, so that they can solve their problem and then move on to more challenging and more interesting problems. But they also get to work with a wonderful community. Okay, so we've talked about open source and standards-based as two key attributes for how you should make your decision. The third one I've highlighted is a DataOps first mentality. So why DataOps? Well, before I get into what kind of DataOps is, briefly, in our view, when you combine open source tooling with a standards-based approach to working, we really do think that it unlocks this improved way of working together. We've seen this in software engineering, where open source tools, standardizing on tools like Git or protocols like Git as well, have enabled better outcomes for software engineering teams. And we think that's possible for data teams as well. So DataOps generally, there's maybe some debate about what exactly it is, but we tend to view it in kind of this lens, and some of this is taken from the DataOps manifesto, if you go online and check that out. But the big things to keep in mind about DataOps is the framing that most everything that an analytics team is producing is code. If you're writing SQL, if you're generating some YAML, if you're dealing with some Ginger or something crazy like that, you're writing code. I don't want to be exclusive. If you're writing Python, Scala, R, that's all code as well, and you should think of it as code. Another big benefit and assertion for DataOps is this idea of disposable environments. One of the things about disposable environments that's really nice is when you're able to spin up a testing or a staging area, you can test your workloads, your analytics, make assertions about data quality. And then once you're confident that everything's good, you destroy that environment and you can release your data to prod. This gives you great confidence in what you're doing. DataOps also implies a level of reproducibility and reuse in your code and in your work. And all of this is in the framework of the assumption that data and the questions that people have are going to be more dynamic and they're going to be continuously changing. The questions that people ask are going to be changing, the decisions that people are going to make are going to be changing, and that all implies that down to the bare level that schemas are going to change, the data itself is going to change, and that your tooling and the ways that you work need to be able to handle that and be dynamic and support that. So with this in mind, like we at Meltano really believe that what DevOps has done for software engineers, DataOps will do for data professionals up and down the stack. And all of it really is with the goal of enabling everyone to collaborate confidently on this data product. So you know that when you want to make a change, that what effect it's going to have, that you can test that out in a safe place, and that you're going to affect things in a positive way when you actually push a change into production. And like our good friend Bill Nye here says, if we think together, we work together, good things are going to happen. And we see DataOps as really bringing that to life. Okay, so these are really the three key attributes for affecting a positive outcome when you're making a tooling decision: open source, standards-based, and DataOps first, because all of this is feeding into the data product. Remember, we want to achieve that good outcome, and all the folks here at this conference meet a lot of these criteria and are excellent choices for any stack. And again, this is in the context of solving a business need. We're not just doing this just to pick a nice tool that's fun to use. There are questions that people have that we want to answer, and the data product that we're building should be able to support that and make our customers, make our colleagues happy. So by choosing a tool that's open source, that's standards-based, and is DataOps first, you're building a strong foundation. And when you have a strong foundation, that means you're achieving this best case scenario. You're achieving a tool, or you have a tool that's able to support a bunch of different APIs. It works with your stack because it's flexible and you can iterate on it. You control it, so there's no need to negotiate new contracts just for additional data sources. You're going to have stronger security, privacy, and compliance outcomes because you're able to control where you deploy it and you're able to understand what's happening. And again, with the open source data stack, you're plugged into a wonderful community of smart data professionals that are solving similar problems and can help you solve your problems as well. And when you have a great foundation and you're at this best case scenario, your stakeholders, your users, and your colleagues are all going to be super happy and thumbs up. So, of course, we think that being Meltano, that Meltano is a great solution for your extract and load. But even more than that, I think Singer, as I mentioned, is a fantastic open source standard for moving data. There's a large community there, and you can run Singer outside of Meltano, but we do think Meltano is a great way to run these different taps and targets and configure it and version control it all within a single repository. If you're interested in more, meltano.com is the website. We are hiring. We've got a lot of great job openings. We also have a wonderful Slack community. You can go to meltano.com/Slack to check it out. You can follow us on Twitter at Meltano Data as well. This is a quick headshot of the team. The whole team got together in Mexico City in July. Our CEO, Dao lives in Mexico City, and we all gathered there to get to know each other. We're all vaccinated, so it was a wonderful time, and probably one of the first times all of us have been able to get together since last year. So if you want to come join this wonderful team, come check out our website. Again, my name is Taylor Murphy. I'm at Taylor Murphy on Twitter, or shoot me an email, taylor@meltano.com. Thank you so much for your time and attention. Hope you enjoyed it, and hope you look forward to hearing from wonderful people tomorrow. We've got Nick Schrock up first, who's going to talk about Dagster. So thank you everyone for taking the time, and I'll talk to you later.